Welcome back to the Deep Dive. If you ever found yourself daydreaming about flying cars or perhaps just wondering where humanity is actually headed over the next few decades, you are definitely in the right place today.
Yeah, we are tackling a massive topic, predicting the future of humanity.
Exactly. And we are digging into a really fascinating, wide-ranging conversation featuring several heavyweight astrophysicists and science communicators. We're talking people like Neil deGrasse Tyson and Charles Liu.
Right, and they recently sat down to essentially tear apart past sci-fi predictions, explore the absolute limits of quantum physics, and build some highly specific models for the year 2050.
And they approach the whole concept of the future not just by throwing out wild guesses, but by analyzing the actual mechanism of prediction itself.
Which is so interesting. It's almost like an autopsy of why certain generations got the future hilariously wrong, and why other thinkers managed to be terrifyingly accurate.
The mission of this deep dive is to extract the sharpest, most mind-bending insights from their discussion. By the end of this, you'll walk away with a clear, well-informed picture of the trajectory humanity is currently on, and we're going to do it without getting bogged down in all that dense academic jargon.
That is the goal. Keep it accessible but deep.
Okay, let's unpack this. I want to start with a massive conceptual flaw in early science fiction. George Jetson is technically a pandemic baby.
I love that fact.
Right. According to the lore, he was born around 2020. But while the show predicted the 2060s, they missed a massive conceptual leap.
What's fascinating here is the fundamental narcissism embedded in how early creators envisioned advanced technology. Early sci-fi operated on the assumption that machines of the future needed to emulate the human form.
Like Rosie the Maid.
Exactly. Whether it was Rosie or Isaac Asimov's complex humanoid robots or just pop culture staples from the 60s, the consensus was that a robot would basically be a mechanical human.
They pictured a literal metal person wearing an apron, physically pushing a vacuum cleaner around the living room.
Right, and they completely missed the paradigm shift of automation. The modern robot doesn't need a face or arms.
If you look inside an Amazon fulfillment center today, it is packed with thousands of robots. But they're just highly efficient, autonomous boxes gliding across the floor, moving massive shelves of inventory.
We didn't need to build a mechanical chauffeur to drive our cars. We just turned the car itself into a robot. A self-driving Tesla is the robot.
That failure of imagination really highlights the trap of linear thinking.
It does. Creators tend to take the technology of their current day and simply draw a straight line forward. They just make it shinier or bigger. The panel points to a perfect historical example from the year 1900.
Oh, this is the best part. When people at the turn of the century were asked to predict the year 2000, they leaned heavily on steamships and railroads.
Because that was the absolute pinnacle of their tech.
So their grand vision for the year 2000 was a massive steamship that would cruise across the ocean, pull up to the shoreline, drop down giant railroad wheels, and just keep chugging along on land.
And because blimps were the cutting-edge aerial tech, they assumed we would all navigate bodies of water using personal inflatable armpit balloons.
Armpit balloons.
Yeah.
Because they couldn't conceptualize the combustion engine or the microchip,
They bolted wheels onto a steamship. We try to extend the present rather than anticipating the complete disruptions that actually define progress.
which makes the discussion around the 1982 movie Blade Runner so compelling.
Yeah.
The film was set in Los Angeles in the year 2019. Obviously, the physical predictions missed the mark.
Yeah, we didn't have off-world colonies or synthetic human replicants walking the streets of LA 4 years ago.
But physically, it missed. Psychologically, it might be the most accurate prediction of our era.
Spot on. The film centers around the Voight-Kamp test, which is a psychological exam monitoring pupil dilation and emotional responses to figure out if someone is secretly a machine.
It is a high-stakes version of the Turing test, or what Alan Turing originally referred to as the imitation game.
And we are constantly running that exact test in our daily lives right now. Every time you read an email, a news article, or a block of text generated by ChatGPT, you are actively looking for the ghost in the machine.
You are scanning the syntax, searching for authentic human emotion. You're trying to determine if there is an actual mind behind the words or just a predictive algorithm stringing data together. We are essentially living out the core psychological tension of Blade Runner.
That shift from predicting hardware to predicting psychological fallout is the defining characteristic of modern futurism. If you look at classic television, Rod Serling used the sci-fi settings of the Twilight Zone to bypass network censors.
He famously called it selling soap. He used aliens and spaceships to comment on 1960s social issues safely.
But modern sci-fi, like Black Mirror, takes a different approach. It assumes a highly advanced technological baseline is already here and entirely focuses on the terrifying ways human beings will inevitably abuse it.
Here's where it gets really interesting. One of the most persistent tropes in modern futurism is treating human consciousness like a hard drive.
Yes, the assumption that we will eventually be able to download a mind, back it up to a server, or plug it into a simulation.
There's a particularly dark scenario discussed in Black Mirror, where a digital copy of a human mind is trapped inside a simulation to serve a 100-year prison sentence.
Experiencing a century of isolation in what is only a few minutes in the real world. It feels incredibly plausible given our current trajectory with neural links and massive data storage.
However, the scientific minds in this discussion introduce a massive, potentially insurmountable roadblock to that digital dystopia.
They argue that downloading a human consciousness might be physically impossible due to the laws of quantum mechanics, specifically a principle known as the no-cloning theorem.
Right. To understand why a brain can't be treated like a hard drive, we have to look at how we currently copy data. When you take a digital photograph, the image is made up of standard bits.
And you can perfectly duplicate that photograph, pixel by pixel, a billion times over, and every single copy will be completely identical to the original.
But quantum computers don't use standard bits. They use qubits.
And the no-cloning theorem dictates that you cannot perfectly copy an unknown quantum state. This is due to superposition.
Which is when a qubit exists in multiple states or possibilities simultaneously.
Exactly. Imagine a coin spinning rapidly on a table. While it's spinning, it isn't heads and it isn't tails. It is a blur of both possibilities at once. That spinning blur is superposition.
If you want to know what the coin actually is, you have to slam your hand down on it to stop the spin. You force it to become heads or tails.
The very act of measuring it destroys the original state. If you measure a qubit to read its information, you collapse the superposition.
So if human consciousness, the complex way our neurons fire and interact, operates on a quantum level, you can never just highlight the mind and hit copy.
You might be able to capture a single freeze frame of a person's brain for one isolated millisecond. But the moment you observe that quantum data, you've altered it.
The living, continuous stream of consciousness is gone. The physics simply won't allow a continuous mind to be perfectly mapped and backed up to a USB drive.
It really suggests there is a fundamental protection built into the physics of the universe that keeps the deepest part of who we are from being easily replicated or simulated.
If human consciousness is that perfectly locked down by quantum physics, it makes you wonder how adaptable we actually are as biological machines.
Which ties perfectly into a thought experiment Tyson and the panel debated regarding the pace of technological change.
Imagine taking an average person from the year 1995 and dropping them directly into 2025. How lost would they be?
The initial instinct is to assume they would be entirely paralyzed. The smartphone didn't reshape society until 2007.
A time traveler from 1995 wouldn't understand social media algorithms. They'd be bewildered by a self-driving electric car, and if they sat down in a restaurant and were handed a plastic card with a QR code, they wouldn't even know how to order lunch.
But the panel offers a brilliant counter-argument. They argue the time traveler would adapt incredibly fast because of a deep human commonality.
Technology is ultimately built by humans to fit human intuition. Humans have been conceptualizing the future for millennia.
They cite a fascinating piece of history to back this up. Lucian, a Syrian satirist writing in the 2nd century AD, wrote a story called A True Story.
And it features voyagers getting swept up in a storm, landing on the moon, and discovering alien civilizations engaged in a massive interplanetary war.
People have been modeling space operas for nearly 2,000 years.
Our time traveler from 1995 has seen Star Trek. They understand the concept of a communicator badge or a sliding automatic door.
Hand them an iPhone, and they'll likely just realize we finally built the digital tricorder from the shows they watched. The learning curve is flat because the interfaces are designed for human hands and human logic.
Still, the pace is undeniable.
This raises an important question. We know we are currently living in an era of exponential technological growth. The panel points out that the volume of scientific research papers published globally doubles on a consistent, measurable schedule.
We are rocketing up a steep exponential curve. But what happens to humanity when that curve inevitably levels off?
To explore the limits of exponential growth, they look back at Thomas Malthus, a scholar from the late 1700s.
Malthus observed the exponential growth of the human population and made a terrifying mathematical prediction. He calculated that humanity would rapidly outgrow its agricultural capacity, leading to inevitable mass global starvation.
But Malthus failed for the same reason the people in 1900 failed: linear thinking. He projected population growth forward on a straight line, but he completely failed to anticipate the application of advanced science to farming.
He couldn't foresee synthetic fertilizers, genetic crop modification, or advanced irrigation.
Today, we produce vastly more food on significantly less land using a tiny fraction of the farming workforce that Malthus observed.
The global food supply is abundant, and the demographic models now predict that the human population isn't going to grow exponentially until we starve. It is expected to safely top out around 10 billion people and stabilize.
The looming crisis forced the innovation that solved the crisis.
With that historical context establishing how resilient our problem-solving can be, the conversation shifts to concrete models for the year 2050. Let's talk about the commercialization of space.
The public assumption has long been that space tourism, lunar hotels, and orbital vacations would be the next major economic leap.
The astrophysicists completely dismiss that. They argue that space tourism will barely be a blip compared to the real driver of the mid-century space industry: asteroid mining.
We are looking at a massive literal gold rush in orbit for rare earth metals. The geopolitical and economic incentives to extract palladium, platinum, and cobalt from asteroids, rather than tearing up the Earth's crust, will be astronomical.
Entire global power structures will shift based on which nations or corporations capture these orbital resources first.
Space tourism will merely be a byproduct, piggybacking on that massive industrial infrastructure.
It perfectly mirrors the early history of aviation. Commercial flight wasn't born because people suddenly wanted to take a vacation to Europe.
Not at all. The rapid advancement of the airplane between 1910 and 1930 was aggressively funded by government contracts to deliver mail and by the massive military demands of World War I.
The panel references a letter written by Orville Wright in 1918 to the Aero Club of America. He expressed profound regret that the airplane, which he and his brother envisioned as an instrument of peace, had been turned into a devastating weapon.
But that massive influx of military and governmental investment made the technology robust, cheap, and efficient enough to eventually support passenger travel. Asteroid mining will be the exact same catalyst for space exploration.
Looking down at our infrastructure here on Earth, the panel envisions a massive shift in transportation by 2050. The era of the human-driven car is likely coming to an end.
They compare manual driving to horseback riding. Today, you don't commute on a horse. You go to a specialized stable or track if you want to ride one.
In 30 years, steering a car manually could just be a weekend hobbyist activity. The actual highways will be dominated by autonomous vehicles traveling at 120 miles per hour, inches apart, with perfect mechanical reflexes.
The massive nuance to this prediction is the infrastructure required to make it happen. For a fully autonomous grid to operate safely at those speeds, the cars can't just communicate with each other. They have to constantly talk to the road itself.
Wiring the physical environment of a dense urban center like New York City or Tokyo with communication sensors is an achievable economic goal.
But doing that across millions of square miles of rural highways, from the plains of Wyoming to the Australian outback, is a monumental logistical challenge. We are likely looking at a highly regionalized future, where true autonomy is restricted to specific urban zones for decades.
That same level of hyper-specific targeted application is predicted for healthcare. By 2050, the era of generic pharmaceuticals that cause unexpected side effects in half the population will likely be over.
Medicine will be dynamically tuned to an individual's unique genetic and hormonal profile, and the most provocative medical prediction involves the human brain.
The mapping of neural pathways is advancing at such a staggering pace that neuroscience is poised to do to psychology what chemistry did to alchemy.
We could see a fundamental shift away from years of abstract talk therapy to treat severe mental illness.
If we can map the brain circuitry with perfect precision, advanced neuroscience might be able to identify the exact synaptic misfire causing depression, trauma, or anxiety.
Medical professionals would be able to cure those ailments through targeted physical interventions, customized medication, or precise microsurgery.
It represents a total transition from viewing the mind as an abstract emotional space to treating it as a complex but entirely decipherable biological machine.
It's a huge shift in perspective.
So what does this all mean? It's easy to listen to predictions about asteroid mining, cars talking to roads, and genetic medicine and feel like we're just outlining a sci-fi novel.
But the panel stresses that these 2050 models are being built on the data points we're generating right now.
How you interact with algorithms, how society manages data privacy, and how we allocate global resources today. These are the raw materials shaping those predictions.
And the data points we are currently generating lead the panel to issue some severe global warnings. They identify a critical tipping point regarding global governance, warning of a very real systemic risk of democratic backsliding.
They note that multiple societies are drifting toward technological authoritarianism. And again, we're just showing the source materials analysis here, but they track how advanced surveillance tools, facial recognition, and algorithmic manipulation are increasingly being used by states to consolidate power and monitor citizens.
If societies allow these digital tools to be weaponized without robust democratic guardrails built in today, reversing that slide into authoritarianism could take generations.
That political instability is running directly parallel to the looming reality of climate change. The models for 2050 don't just predict warmer weather. They predict massive logistical and humanitarian crises.
We are facing unprecedented challenges regarding climate migration as arable land shifts and coastal cities are forced to deal with rising sea levels.
It's striking how early certain creators modeled this reality. Steven Spielberg's film AI Artificial Intelligence, released back in 2001, visualized this exact scenario.
The film features a fully submerged Statue of Liberty, serving as a stark warning about the extreme physical environment our future technology will be forced to operate within.
Despite the weight of those existential challenges, the astrophysicists made sure to include some genuinely optimistic and highly entertaining models for the near future.
I love this one. Within the next 25 years, the panel predicts we are going to see a professional sport played entirely in orbit.
Zero-gravity spaceball. Picture the sheer athletic mechanics of a sport designed for 3 dimensions without gravity, and imagine the massive broadcast rights for a championship game played on a commercial space station.
If we connect this to the bigger picture, what this entire deep dive into Tyson, Liu, and the rest of the panel reveals is the true utility of prediction.
Building models for the year 2050 isn't about perfectly guessing the arrival date of orbital sports or autonomous highways.
Models are always technically wrong, but they are incredibly useful. They act as mirrors.
Our predictions and sci-fi stories reflect what we value right now, what we are terrified of losing, and what kind of foundational infrastructure we need to start pouring concrete for today.
They force us to examine our current trajectory by showing us the logical conclusion of our present actions.
Which brings us back to that mind-bending concept from quantum physics. We talked about the no-cloning theorem. The fact that in the quantum realm, the simple act of observing a state permanently destroys its current form and forces it into a new reality.
It changes everything.
Exactly. So if we apply that logic to humanity as a whole, it leaves us with a profound question. Does the very act of trying to predict our future fundamentally alter the path we are on? Are our dystopian sci-fi movies, our technological warnings, and our 2050 scientific models just a massive form of quantum observation? By naming and modeling the year 2050 today, we might be guaranteeing that the actual future will be something we can't possibly imagine right now, something to mull over as you navigate the rest of your day. Thank you for joining us on this deep dive. Keep your eyes on the future, and we will catch you next time.